So today I'm slightly in a noisy environment, so kindly ignore the noise. So step one is always to pause the video so that you write the question somewhere. Then step two is normally to subscribe. That is, if you have not subscribed, kindly support the program by your single subscription. The first question, a straight line whose equation is negative 2x plus 3y plus 2 is equals to 0 meets the x-axis at Q. Determine the coordinates of Q. So we say that if it is cutting the x-axis at Q, remember this is the x-axis, this is the y-axis. So at x-axis, the value of y is 0. Therefore, we say that at x-axis, the value of y is 0. So substituting in this equation, where there is y with 0, you come up with the value of x as positive 1. When x is positive 1 and y is 0, the coordinate of Q becomes xy, which is the value of x as 1 and the value of y as 0. The second question is a second line L2 is perpendicular to L1 at Q. Find the equation of L2 in form of y is equals to mx plus c, where m and c are constants. So for perpendicular line, we say that for perpendicular line, that is line L2, m1, m2 will give you negative 1, or the product of the perpendicular lines for their gradient is normally negative 1. Remember, we are supposed to find the gradient of this line L1. So line L1, we make y to be the subject. So making y to be subject, line L1 becomes 2 over 3x minus 2 over 3. So therefore, m1 is this one attached to x, which becomes m1 to be 2 over 3. So therefore, m1 times m2 will give you negative 1. So m1 is this 2 over 3 times m2 that we doesn't know will give you negative 1. Multiplying both sides by the reciprocal of 2 over 3 leaves you with m2 as negative 2, negative 3 over 2. So proceeding, we say that now our gradient m2 for the second line, which is negative 2 over 3, at Q, we find the value of Q, which was the x-intercept as 1, 0. So therefore, we are picking this gradient to be gradient is equals to change in y over change in x. So it becomes negative 2 over 3 is equals to y minus 0. This 0 over x minus 1, this 1. When the gradient is negative, we can take the negative to be either for the numerator or for the denominator. Giving the numerator the negative, this 2 becomes positive. So when you are cross multiplying, it becomes 2 times y minus 0, which is 2 times this one, then is equals to now negative 3 times the lower one, this one, so that you open the bracket. When you open the bracket, you get that y is equals to negative 3 over 2x plus 2 over 3 as the equation of L2. So from L2, we now go to the second part. So the next second part is part C. Part C is saying that a third line L3 passes through negative 4, 1 and is parallel to L1. So find the equation of L3 in form of y is equals to mx plus c. So it's passing at negative 4, 1, and remember they are parallel. So L3 is parallel to L1. So we come and say that for parallel lines, their gradients are normally equal. Remember, we had found earlier in part 1 that the gradient of L1 is 2 over 3. So we say that 2 over 3 is also the gradient of our L3 that is passing through negative 4, 1. Having this one as our gradient is equals to y now minus the value of y is 1 over x minus the value of y, x is negative 4. So it becomes x minus minus x. So remember, negative and negative gives you positive. So when you are cross multiplying, this one goes with this one, then this one with this one. Opening the bracket, you get that y is equals to negative 2 over 3x plus 11 over 3. Then the last part is to find the point of T, the point T at which L3 is intersecting with L2. So you want to see if lines are intersecting, how do you find it? So you say that the coordinates of point of intersection of T is where the two lines are equal. So L3 is equals to L2. Remember, we have found L3 to be 2 over 3x plus 11 over 3. So it is equal to the L2 that we had already found, so that which was y is equals to negative 3 over 2x plus 3 over 2. So we are saying that this one is equals to this one, from this one that L3 is equals to L2 where they are intersecting. So therefore we take this one, which is this one, so is equals to this other y, which is this one. So collecting like terms, this one moves on the other side, which becomes positive, and this one moves on this as which becomes negative. So making x to be the subject will give you the value of x. So the LCM is 6. So therefore, we say that if the LCM is 6, we find that the denominator now, the addition, gives us 13 over 6x. On this other side, the LCM is also 6. So the addition gives us negative 13 over 6. So multiplying both sides by reciprocal of 13 over 6 leaves us with x as negative 1. And if x is negative 1, we now come and substitute in either of the equation. You can take this one or this one. So substituting in this one, so you find that this equation that you have picked is negative 3 over 2, this one plus 3 over 2, but our x is negative 1. So substituting x with the negative 1 gives 5 as the value of y. So if the value of y is 5, the t is given by xy, so therefore the value of x is negative 1, the value of 5 is 5. That becomes the point of intersection. In conclusion, therefore, we are supposed to note that the gradient is derived by or is given by change in y over change in x. If lines are perpendicular, their gradients, that is m1 times m2, is supposed to give you negative 1. If the lines are parallel, their m1 is equals to m2, or their gradients are normally the same. Then we say that at point of intersection, the two equations are normally equal. So you can solve them simultaneously, you can solve them the way you have solved them, or you can even use the matrix method. Then you can also say that at the x-intercept, the value of y is 0. At the y-intercept, the value of x is normally 0. Then the equation can be written in the following forms. It can be written as y is equals to mx plus c. It can be written as ax plus by plus c is equals to 0. Or it can be written in double coordinate form, which is given as x over a plus y over b is equals to 1. If you have any question, as usual, drop your question on the email provided at our top page. Thank you. Kindly subscribe.